our next speaker is Professor Frédéric Bosché from the University of Edinburgh. Thank you, Fred. I know it's very late over there in Scotland, so thanks for joining us. Professor Bosch's talk is Scan-to-BIM for energy and efficiency renovation for buildings. And the floor is yours, Fred.
Yes, can you see the screen and can you hear me?
Yes.
Excellent.
For both.
Thank you very much. Okay, so I mean, you introduced me. Thank you very much. I'm from the University of Edinburgh. I'm actually in the School of Engineering. I teach in construction, but I've done research at the interface between computer science and construction engineering for a number of years. I'll start my talk. In fact, Eleni had a little slide about this as well, but I'm an editor of automation construction, and I've done a few presentations recently where I looked at some statistics in the journal, and I thought I should share a few here because I thought it's relevant. This is just to give you an impression first. This is the number of papers that have been published in the journal over the last 15 years. You see, it's been kind of almost, I think we are getting used to the exponential curve after COVID. So it looks a bit exponential, and in fact it is. In 2021, we're only halfway through the year, and we've already pretty much matched the number of publications we had last year. The number of submissions just skyrocketed. There's a lot, but more than the number of publications is what the publications are. And these are the number of publications that actually have the word BIM or digital twin, which for those who are in the domain are essentially, let's say, an extension of the BIM concept. And you can see that about 25% of our papers refer to building information modeling. And certainly can touch on different aspects of building information modeling, but certainly a number of those papers are related to computer vision and related applications like Scan-to-BIM that people were competing on in this workshop. And I do show the digital twin curve at the bottom just to show that this is a really new thing, but it's kind of going up slowly. In contrast, you can see if you look for the word, I put scan here, but it's not just scan, it's actually a number of different words, keywords that I used. But you can see how the domain of 3D laser scanning and 3D data acquisition has been growing steadily over the last 15 years. And then you can see also the papers that actually talk about both, okay, that refer to both BIM and scan. And that's about 3% of our publications. Now, a trend that you would expect is the world of artificial intelligence. The terminology there shows like significant increase in the last 5 years. In fact, myself as an editor, I seem to be only handling papers in the area now, but it's really 1 in 5 papers that is in the domain. And again, in relation to building information modeling, there's been a slow increase in the number of publications there. So I think that's quite interesting, and it does relate to the workshop today. So I hope you find that interesting. Some of you don't publish in automation construction, but a number of people do, especially people who are more maybe from a civil engineering, construction engineering, but we've applied computer science or applied computer vision here. I'll just do a quick review of Scan-to-BIM in the next few slides. But really my presentation today is to talk about a workflow that we are developing as part of a EU project called BIMERR. And in this workflow, we, the University of Edinburgh, contribute some Scan-to-BIM algorithm, but I actually, I will talk about a broader workflow here and the integration into this. I think one of our speakers, first speaker, I think, discussed the importance of looking at the use case, and when you start applying this in context, and there are various issues that come up. So I think that would be quite interesting, and it's quite complementary to some of the works we've seen. So just to review, in fact, a lot of the presentation we've seen today follow a bit this kind of approach of Scan-to-BIM that is generating a 3D semantically rich model of the built environment, where, well, tend to look for the height of the ceiling and the floor, and then to segment the rooms, find the room boundaries, and then eventually there is some modeling of both the walls, the openings, and there's a creation of a 3D volumetric model or a 2D floor plan. Now, the way this is modeled is an important thing that I think the second place winners from Munich, the presenter touched on, which I will cover a little bit later as well. And if you look at the room segmentation, there has been historically a lot of approach that were based on surface detection and segmentation. And then there are different methods used to filter and connect the surfaces. There's certainly some work that looked at modeling and checking the typology, making sure that walls are connected to floors, for example, or ceilings. So ensuring a semantically logical labeling and modeling of the point clouds. And then obviously with the development of artificial intelligence and machine learning in particular, there has been effort to kind of try to do everything at once, essentially. This is the work from Iro, for example, that was published back in 2016, that has a combination of room detection in the middle, but then within the rooms trying to do the detection of all the different components, both structural but also furniture, etc., using some classifier. Actually, it's not machine learning. I think it's I mean, it's a machine learning, but it's a classifier that uses sliding boxes, if I remember correctly. And there's been quite some excellent work published recently, and today I've seen some presentations earlier and seen some excellent work. This is one paper that was published last year by two colleagues from Belgium, I think. And in their work, so they do interesting work there, but also in their work they talk about the need to not just create geometries in the traditional sense of it, but actually meaningful geometries that are useful for construction software. And in that particular case, people tend to try to model the completed building using a format called the IFC, a schema called the IFC. So the IFC is a complex schema, but it enables people to generate semantically meaningful component like walls, like windows, like doors, like floors, slabs, you name it. It's really driven by construction and the built environment. And so there is some effort in some of the Scan-to-BIM papers to actually not just finish after the detection of the walls and the windows, etc., but actually model them. And there are different ways to model. You can model the components, the walls, the floor, ceilings, or you can also model the spaces. And this is actually important from an energy analysis viewpoint, actually, and I will touch on this a bit later. So this is a bit short review, but it provides a bit of background, which I think is useful. And now I will talk to you about some work that we are doing as part of the BIMERR project. BIMERR stands for BIM-based holistic tools for energy-driven renovation of existing residences. It's about a €7 million project that lasts 42 months. It's within its last year. And the work I present today involves 3 partners, but actually the whole project is much broader and involves 15 partners from 10 member states. So I only touch on one piece of it actually, but there's a broader issues covered in the project. That's the, I don't know how you call that. It's not a workflow, it's the concept, let's say, diagram of BIMERR. On the left-hand side, we have some essentially data acquisition means using reality capture, like laser scanning in particular, and the need and tools to create building information models. Sorry. but there are other data acquisition means, but that serve other purposes. For example, we have some apps to engage with residents, and also some sensors in the rooms of the apartments to monitor various information like temperature, etc., and much more. And this information essentially is collected into a central repository that aims to maintain semantic connectivity between all the different types of data. And this data is then used by a number of applications. And here, today, we're interested in the Scan-to-BIM that generates a BIM model and how this is subsequently used. I apologize. Subsequently used for enabling designers to decide what should be the most appropriate renovation changes to the building in order to make them more energy efficient. So that's the workflow that I will talk about. The workflow involves actually four tools, but I will really talk about three. The first one is the Scan-to-BIM tool, which is a tool we have been developing. The second one is the BIM management management platform, sorry. That's essentially handling BIM data, the IFC data we generate, and it has a very important role in checking the BIM content and providing feedback on this. If it doesn't pass, the good thing is we have a really good workflow that works where people can use existing tools from industry, and this is very important for when you engage with stakeholders from industry. They want to be able to correct the model. In fact, with all the best attempts from all people submitted today, we don't generate perfect models from our Scan-to-BIM tools. So there is a need to be able to revisit those models and correct them. And then there's a second step where we focus on not the geometry of the main structural component, but we look at actually adding some mechanical, electrical, plumbing equipment, but also adding materials information for the walls, etc., which obviously is not visible from the point cloud, but is required for energy purposes. And I'll talk about zones as well. And again, all this model that is generated is checked again by the BIM management platform. And if this is passed, then this is sent to the Renovation Decision Support System tool, RenoDSS. I hope my voice will hold. So I'll go through this pipeline here and hopefully make it interesting. Let me give me just a second. I'm quite tired, I guess. Okay, so Scan-to-BIM tool, it's actually not a revolutionary tool we developed, although maybe we could have attempted to enter the competition. We were just a bit too tight. We were not ready, let's say, to enter the competition. But we have a similar approach to a number of people, but we haven't tried to implement any machine learning based approach yet, at least not for the structural modeling. But we do a floor detection, and then within each floor, we do a wall detection. We actually do this based on analyzing the ceiling data. We found the boundary there. We are not looking for Manhattan walls specifically, but we are looking for straight walls. That's one of our assumptions. And then we also use some techniques similar to the ones we've seen today to identify the different openings in the building, both doors and windows. And then we model them and add them. Now, after this, we don't stop there. We also create, so we create an IFC file. And I think one of the speakers was saying like it's challenging to create IFC files because they don't necessarily look great, but we've been working on this ourselves, and we're able to open the files in Solibri, which is a tool used in industry to check IFC files and to model them, to visualize them. And it worked quite well. The boxes that appear in yellow here are actually the spaces. So they're essentially the rooms that we identify in the model, and they are actually modeled in the IFC file as spaces. And beyond those spaces, we also create what are called second level space boundaries. Oh my goodness. Give me a second, I'll get more water. Thank you. Cheers. And these second level space boundaries, they are actually different type of space boundaries that are required, specifically required for energy analysis. So they really look at the boundaries and the connections between different spaces, and they are modeled specifically to, this representation is very useful, is actually required for energy analysis. And again, we are able to open those in a Solibri and check that actually our modeling was correct. But it does at times appear that our model fails. So it's important that we use the BIM Management Platform to check the geometry. This is actually developed by our colleagues at UCL. It's not Eleni, by the way, but it's a colleague of hers. And they've developed this platform, which is a very smart platform actually to handle IFC files. And what they do is they can open the file and they can check the geometry and ensure that it's actually compliant. And so here you can see an example where it's showing different boxes in yellow, in red, and the one in green here is selected. And these are actually clashes. And they can be clashes between components, like two walls that are not connected correctly, whose geometry intersects, or it could be a clash between a wall and space and other ones. So they give this, and these visual reports, which are very useful. And what happens then is that the person can then reopen our file in an authoring tool, like I think Ellen didn't want to name, but I'll name some famous ones like Revit and ArchiCAD. And we're able to open our files there, check what is wrong and correct whatever is required, and then resubmit to the BIM management plan. So obviously we aim to have the best file possible through our Scan-to-BIM automated process, but it doesn't always work. In fact, it generally doesn't fully work. But our goal currently with our validation work in the BIMERR project is to demonstrate that even if work is required to correct our models, not just making sure that our model the space correctly, but also that the geometry doesn't have any clash, etc. These processes can be much more efficient than doing everything from scratch by hand from the point cloud. And oh yeah, sorry. And this is actually another one, which is a space clash here. So once we have passed the geometry check, the person can reopen the model in our tool, And the next process is some bit is automated and some bit is manual. So what we do in our pipeline is that alongside the point cloud, we have pictures that are acquired of the environment, and these pictures are actually processed using photogrammetry, just like in similar ideas what Reconstruct does. So the pictures are essentially aligned with the point cloud, and we process the pictures to detect various type of components inside the buildings. So here you can see a detected air conditioning component, and then we are able to reproject that in our point cloud and in fact in the IFC file, and we can expand the model with these components in the IFC file. And these units are important. We can detect at the moment just a few components, but like radiators, air conditioning units, things that are very relevant to energy simulation. But we have also extended this to some electrical components like sockets and switches. This has less value for energy analysis, but it can have more value for construction planning. So if you have to renovate a wall and you know that there's a number of electrical components on it, it's good to know ahead of time because the work will entail additional tasks. Oh, so this is showing again. I meant to add a BIM model showing the MEP components, but actually I forgot to add that to my slides. But essentially, once we have that, we can reproject on the IFC file. We add the components, and then we can actually do a little bit more that I will present soon. The next thing we do is that to do energy analysis, you need to know what the walls are made of, and what the windows are made of, and what the ceiling and floors are made of. And to do that, you need to essentially create the layers of materials. And one thing that the project has done is to create a material and component database. This is done by our partners, Xylem Technologies, based in Austria. And they took three well-established databases and they combined them. They combined all the information together, and our tool has access remotely to that online database. And so it's a bit ugly right now, but we'd like to put a 3D interface to this. But essentially, we have somebody can go through the 3D model, select one of our doors, for example, or slab or a wall. And if you take a wall, for example, we have a window that opens up and the person can edit what are the materials that made up that wall. So obviously, if you have a point cloud or a picture of a room or a building, you cannot deduce what the wall is made of. So that process has to be done manually, because the people will either use external data or external information they have from historic drawings, for example, or they will have done some non-intrusive or maybe destructive intrusive sensing in order to figure out what the walls are made of. And so they can then enter information about the walls. And this is actually, they don't just enter random things, they actually pick the components from the database that we have created with our colleagues. Okay, and this is important because the database is not just about a database of names, etc. The database has energy efficiency parameters and actually also cost information, etc. So there's a lot of additional semantic data that is valuable. So the person can do this. Here they can also select what is the exact model of different types of, for example, mechanical components. So the radiators that were detected earlier, typically detectors will just say it's a radiator. What we can do here is actually pick up a radiator from the database that corresponds to the radiator in the building. And we also have standard radiators that people can just put in and then edit some of their properties. And finally, there's something that has to be done. It's not very important to present here, but essentially, you need to identify the zones. What we mean by zone is essentially when you have central heating, you need to tell in your energy model what the central heating is heating. So which rooms are connected to the central heating, for example. So you need to figure out how that works. So in our case, mainly heating is done within each flat. So we have to create, each flat is made up of spaces, and we make each flat one zone. Okay. But if you have a building where you have central heating done for the whole building, then you need to select all the rooms and make them one zone. And again, this is something you cannot define from point clouds, but that is required later on. And once we've entered some of the information here, this is sent again to the BIM Management Platform, which will actually check this using what is called an MVD. So for those of you who are not in the domain, an MVD is essentially a means to check that a BIM model contains the right data for the purpose, for the defined use case. So in our case, we created an MVD that says, in order to conduct energy analysis, we need to have IFC models that not only have the geometry, but that for all the walls, we need to have materials, and the materials must have this kind of information attached to them. And so the BIM management platform checks all this and provides a report. And if insufficient information is provided, then it can be reopened in the Scan-to-BIM tool. For example, we forgot to allocate a component. For example, take a radiator, and we forgot to say which radiator it was. That will be detected and we can check it. And yeah, this is the report that they provide, so I'll just skip that. And finally, this information goes in the RenoDSS. I don't want to spend too much time on this at all, but our colleagues in Xalem created that tool where you can open the IFC file. You can see information about all the components inside the IFC file. You can see if some information is required, not so much for material properties, but it could be LCA, so life cycle analysis. This is not information that would come from our tool, but from their database. So their database may not be entirely complete for certain properties. And then they are able to run an energy simulation tool, which is developed by another partner, Hypertech Energy Labs. And from this, they can get economic information, energy information, and sustainability information. And that they can use this to say, okay, this is how the building performs now. And that helps define, well, that's the baseline against which the designer needs to identify the most adequate renovation strategy. So they can take that into the next step, where their tool, you can review the different components and you can decide. So here there is a view where you can select all the components of this type, and you can see them in the 3D model. These are essentially the exterior walls. Here it shows you what are the layers for the exterior walls. Then you can decide what type of refurbishment you want to make. And once you've decided this, then you can start editing. So which layers do you want to keep? Which layers do you want to remove? And what are the new layers you're going to put, etc. And given this information, you will have one, for example, renovation option, and you can create multiple renovation options. And at the end, you can review all your renovations options and check them against your different targets of life cycle and cost, construction cost, energy consumption, heating, etc., etc. And you can, export reports and all the normal stuff. So all this is possible because from the outset, from the Scan-to-BIM, and we aim to provide all the necessary information that enables, because this is where the value happens. So we need to make sure that the whole value chain is complete. It goes, we have the end goal in mind from the very beginning. And as I say, I don't want to go beyond, but we have all the tools here. We have the BIM platform in the center here is actually much more than a BIM platform. It handles various types of data that is used even for the energy analysis. We use weather data, climate data, for that aspect. And we have other applications that are dealt with by our other 11 or 12 partners. Okay, and that's me for today. I hope you found this interesting. I'd like to thank my colleagues from UCL and XRM who provided me with some of the input slides here. That's not at all my work, but it's great work they've been doing themselves. Thank you. And sorry for the coughing.
Oh, no worries. Thank you very much, Fred, for the great talk. We have time for a couple of questions. The first question I see here is is your Scan-to-BIM structural module fully automatic?
Yeah, so that part is fully automated. So essentially, it could have maybe been sent to the competition. I don't think it would have performed extremely well, but it would have certainly done reasonably okay. The interesting thing is that we have some real examples also coming from our partners. We have like a 10-story apartment building data that a partner is giving us. But we have another one much more complicated, only 3-story from Poland, but much more complicated geometry. The chances are our tool will fail. But what is important is that we've been working a lot with our colleagues at UCL to demonstrate the pipeline where you can, especially, I mean, it's really their work really, to demonstrate how we can return to tools like Revit and ArchiCAD and complete the model and proceed. So yeah.
Okay, great. Thank you. And maybe just one more quick question before we move on to the panel discussion. Could you give an example application of material information and BIMs of existing buildings and what kind of material information is needed?
Thanks, Thomas. Nice to see you here, actually. I'm not too sure what you mean. I mean, I think I covered a bit of that. So in a design model for construction, for example, we have the materials of the layers of the wall. So we need to know if we have concrete blocks and then what kind of insulation is there and then what kind of different layers, essentially, all the way down to the final painting layer if you need to. This is the kind of material, but we also actually, our editor enables us to edit openings materials. So what's the window frame and whether the windows are double, single, triple glazed. And in fact, we could edit individual parameters, but the important thing we had here is the connection with the database, so that the user can just say, actually, this is a double glazed window with PVC framing, and that'll give reasonably good information. We have standard and we have manufacturer data.
All right.
Okay, thanks, Thomas. I've seen your comment.
Yeah. Thank you, Fred.